G'day YouTube, Warbles on a lot here. Welcome to a video shot in Hammock-Cam. And that's fairly appropriate because most of the world is sitting on their arse and doing nothing about global warming, so let's have a look at December 7th, New Scientist, cover story, main article. Titled, "The Heat is Still On. Global warming hasn't stopped, despite what some skeptics claim. Michael LePage gives the lowdown on the slowdown. Warming has not peaked. Instead, it looks as if the sea is taking up the strain." Looks like some bad news ahead. Maybe we better take on some Dutch courage, eh? Malt liquor video. Cooper's Sparkling Ale, 5.8% alcohol volume. Yeah, right. Well, that'll put a bit of a wobbly boot on you, won't it? Global warming on pause, unquote. Why has global warming stalled, unquote. Has global warming stopped, unquote. If you have been reading the papers of late, you may be under the impression that global warming isn't proceeding as expected. What most mainstream media have been careful to point out, while most mainstream media have been careful to point out that the apparent lack of recent warming is probably just a temporary hiatus, a few outlets have suggested there is more to it than that. The climate may be heating up less in response to greenhouse gas emissions than was once thought, one magazine claimed. What is going on? Has global warming really slowed or stopped in recent years? If so, why? And does this mean the world won't warm as much as previously expected? Claims that global warming has stopped are nothing new. The vast majority don't stand up to scrutiny, but the latest talk appears to be different. This time it's climate scientists themselves talking of a slowdown. And in the past few months they've even begun to publish papers about it. This past decade has been the hottest since records began. That's not in dispute. However, the average surface temperature of the planet seems to have increased far more slowly over this period than it did over the previous decades. The rate of warming was just 0.04 degrees Celsius per decade from 1998 to 2012, significantly lower than the average 0.11 degrees Celsius warming per decade since 1951. See, how much has warming slowed? Right. We move on to that. How much has warming slowed? The surface of the planet is now more than 0.6 degrees Celsius warmer than it was in 1951. The pace of warming has varied tremendously over this time. It started accelerating in the 1980s. It hit 0.28 degrees Celsius per decade in the 1990s, but fell to 0.09 degrees Celsius in the 2000s. So the planet is not warming as fast as it was, but the details vary greatly according to how you calculate the trend. Pick the very hot year of 1998 as your starting point and the slowdown appears most dramatic. The rate of warming from 1998 to 2012 was just 0.04 degrees Celsius per decade. If this rate continued, the planet's surface would be just 1 degree Celsius hotter in 2100 than in 1950. Which is well under the dangerous level of 2 degrees Celsius, but these figures are based on the global surface temperature record compiled by the UK's Hadley Centre, and its record does not include the fastest warming region on Earth, the Arctic, as there are so few observations there. According to NASA's record, which guesstimates Arctic temperatures based on the nearest weather stations, the warming rate was 0.07 degrees Celsius per decade from 1998 to 2012. And according to a study out last month by Kevin Cowtan of the University of York, UK, which extrapolated Arctic temperatures from satellite data, the 1998 to 2012 rate was 0.12 degrees Celsius per decade. If he is right, warming has only slowed very slightly from 0.18 per decade in the 1990s to 0.16 degrees Celsius in the 2000s, which would still take us over the danger limit of 0.2 degrees Celsius by 2100. Cowan's study is not likely to be the final word. Satellites measure temperature far above the ground, so extrapolating to the surface is difficult. But whatever the precise figures, there is every reason to think warming will not only continue, but accelerate greatly over the coming century. See the main story. To which I now return. Yet this doesn't necessarily mean that climate change has stopped, any more than the very rapid warming seen in the 1990s meant that it had accelerated. Instead, a standard explanation is trotted out to explain these changes in pace: natural variability. Surface temperatures go up and down all the time because of changing winds and currents, and phenomena such as volcanic eruptions. This variability can easily obscure the underlying warming trend. Remove the known contributions of natural variability from the observed surface temperature and you see a much steadier warming trend. See Putting the Brakes On, page 36. Putting the brakes on. If you look only at the surface temperature records for the last couple of decades, the rise in global temperatures seems to be slowing. That's the purple line. The purple line would be that one. However, if you add in the short-term variations in solar emissions, volcanic eruptions, did you get that, VB Ed, in Perth, where you got 44 degrees and you're sweltering, and the El Nino Southern Oscillation, this slowdown almost disappears. Blue line. There's the blue line. But considering that both those two lines are made up of all of this extremely wobbly shit, anybody who wants to base their arguments on 1 or 2 years' worth of discrepancies is probably talking out of their arsehole. That's my opinion. Returning to the main story. Yet glibly blaming natural variability for recent surface slowdown is unlikely to satisfy those who are genuinely sceptical about global warming. How, they might ask, can we be sure that the plateau in surface temperatures is due to natural variability masking the underlying warming trend, and not because warming has actually slowed or stopped? To answer this, it helps to think about heat energy rather than temperature. The reason the planet has been warming over the last century is because rising levels of greenhouse gases act like extra blankets, reducing heat loss from the top of the atmosphere. In terms of heat, there are 3 possible reasons why Earth's surface temperature has not increased much recently. The first is that the sun has been getting dimmer, meaning less heat is arriving. The sun's heat output rises and falls in an 11-year cycle, and measurements by spacecraft such as SOHO show it did dip particularly low recently. I would say, gee, the sun's trying to compensate for our ridiculous atmospheric gas mix changes, but that's just me. The second reason could be that more heat than usual has been escaping from the top of the atmosphere. One possible cause is, as we turn to the next page and we flip the magazine, increased levels of sulphur aerosols in the atmosphere. These aerosols don't prevent the sun's rays entering our atmosphere, but they do reflect more of the sun's heat back into space. Sulphur aerosols are produced by volcanic eruptions, one of the big causes of natural variability, as well as from coal burning and other human activities. Sure enough, levels of sulphur dioxide have risen in the past decade, mainly due to lots of small volcanic eruptions. Lastly, it is possible that the planet has still been gaining heat, but that more of it has ended up somewhere other than the lower atmosphere. Well, if the heat gradient from the lower atmosphere to the ocean increases, surely the ocean will commence to suck up more heat. That's my guess about what they're going to say. And yes, this is the first time I've read this article, so we're all learning at the same pace. The most obvious culprit is the ocean. Water covers more than 70% of the planet, and the stuff has a huge capacity to absorb heat. Around 3,000 times as much energy is needed to warm a given volume of water by 1 degree Celsius as is needed to warm the same volume as air. Here's another way of thinking at it. Water has 10 times the thermal mass of steel. Water takes so much heat to change its temperature that it takes the same amount of energy to raise 1 teacup of water by 1 degree Fahrenheit as it does to lift it 768 feet vertically into the sky. That's why nobody builds towers to put water tanks on to run hydro schemes with solar pump storage hydro. You can't build a big enough tower. It's easier to heat the water and store hot water in an insulated tank and use that. Arr. Observations show that a whopping 94% of the heat energy gained by the planet since 1971 has ended up in the oceans, with another 4% absorbed by land and ice. See, where is all the heat going? Page 37. Okay. Page 37. Where is the heat going? There we go, I found it. See? Different parts of the planet are gaining heat energy at different rates, with the ocean absorbing the vast majority. There we have the upper ocean. What's this energy in 10 to the 21 joules? Upper ocean about 260 times 10 to the 21 joules. The deep ocean only 100 times 10 to the 21 joules. Ice is like less than 10, land is less than 5, and the atmosphere is less than 2. So that's like the heat that the global warming skeptics are talking about is that noticed in the atmosphere, which is the tiniest, weeniest, darkest little bit of that graph there. Most of the heat is going into the upper ocean and the deep ocean. Some more is going into the ice, and aren't we noticing that? Greenland melting, the northern ice cap melting. Yeah, we're seeing that. It's a happening thing. So, all the surface warming since 1971 is due to just 2% of the heat. If just a little more heat than usual has been going into the oceans, it will have only a slight effect on ocean temperatures because of water's huge capacity to absorb heat, but a large effect on atmospheric temperature. And several studies suggest that recently the oceans have indeed been soaking up even more heat than normal. Why? Well, heat constantly sloshes back and forth between the oceans and the atmosphere. This is the main cause of natural variability. What happens in the vast Pacific Ocean matters the most. During a phenomenon called an El Nino, when the easterly winds spread hot water across the top of much of the tropical Pacific, so much heat flows into the air that the entire surface of the planet warms. There was an especially strong El Nino in 1998, which is why it was such a warm year. During the opposite event called a La Nina, when westerly winds spread upwelling cold water across the sea surface, the tropical Pacific soaks up so much heat that it cools the planet's surface. And lately there have been lots of La Ninas. 3 in a row. We have not seen a major El Nino for the past 15 years, says Shangping Zi of the Scripps Institution of Oceanography in San Diego, California. See below. See? See below. Why didn't models predict the slowdown? Prediction is not just very difficult, it is sometimes impossible. The slower rate of surface warming over the past decades seems to be due to a combination of factors, including a series of cold La Ninas in the Pacific, an extra low solar output, and a higher volcanic emissions. See main story. We've done that. If you thought you heard a glug, glug, glug there, you could be right. None of these kinds of natural events can be reliably predicted. Perhaps it isn't surprising then that out of 114 runs of the latest models, just 3 produced a trend from 1998 to 2012 as low as that observed. The reason models fail to predict short-term trends is not that the models don't include natural variability, they do. Individual runs of climate models zigzag up and down wildly and often exhibit periods of a decade or more when surface temperatures barely increase or even cool, despite a strong long-term warming trend, just as we are seeing now. Rather, the problem is that the timing and magnitude of natural events in each model run differs from that in the real world. In one model run, for instance, there might be a La Nina in 1998. In another, conditions might be neutral, whereas in the real world in 1998 there was an exceptionally strong El Nino. But what if instead of allowing La Ninas and El Ninos to occur spontaneously, you tell the model when they really did take place? Shangping Zi and Yu Kosaka at the Scripps Institute of Oceanography in San Diego, California, recently did this, for the first time, by feeding the recorded values for sea surface temperatures in the tropical Pacific into a model. This, quote, historical model reproduced the observed global surface temperature from 1950 remarkably closely. See that in Nature, volume 501, page 403. It even reproduced many of the regional and seasonal characteristics of the slowdown. This close match was achieved even though the model did not include volcanic emissions after 2005 or the recent solar low. All this suggests to me that for the current hiatus, the Pacific surface cooling is the major driver, Z says. The unpredictability of natural variation means climate models may never be any good at forecasting for the next 5 or 10 years, though some groups are trying to adapt them for this purpose. The key point is that short-term natural variability does not matter when predicting how much the world will warm over the next century or 3. So the fact that models did not predict the slowdown is no reason to doubt their long-term predictions. Think of it this way. We can be sure that the next winter will be much colder than the summer, even though we can't say how much the temperatures will change from day to day. But there have been several long-lasting La Ninas. A model study by Z, published in August, showed that this alone could explain the slower surface warming. Whatever the cause, observations suggest that more heat than usual has gone into the ocean, and particularly the deep ocean. That's in Geophysical Research Letters, Volume 40, page 1754. The ocean is warming at depth, says study author Kevin Trenberth of the National Center for Atmospheric Research in Boulder, Colorado. So some researchers such as Trenberth and Zai think the slowdown is mostly due to the oceans. I agree with them. However, under the heading Unknown Oceans, not everyone is convinced. The Argo network of probes for measuring ocean temperatures, see Plumbing the Depths, page 38, Plumbing the Depths. The Argo network of 3,600 probes measure salinity and sea temperature down to depths of 2,000 metres. Over 1 million profiles have been collected around the globe since deployment began in 2007. Day 1, probes measuring 1.5 metres long are put in the ocean over a wide area. They drop to a depth of 1,000 metres. Here they drift with the current for around 9 days. Day 9, descending to 2,000 metres, the probes then ascend slowly, taking temperature and salinity readings on their 12-hour rise to the surface. And day 10, probes transmit their recorded data to a satellite and a new cycle begins. The Argo network was only completed in 2007, so although we have a good idea of how much heat there is now in the oceans, it's hard to be sure how much it has changed in the past. We are also uncertain about the effects of aerosols and so on, which leaves room for debate. The mainstream view expressed in the latest Intergovernmental Panel on Climate Change report is that about half the surface slowdown is due to the oceans, and the other half is due to the sun and extravolcanic aerosols. It's 3 or 4 things added up, agrees Gavin Schmidt at the NASA Goddard Institute for Space Studies, but he is not convinced that the oceans are one of those things. They have continued to soak up heat, but we can't be sure that they have been soaking it up faster than usual, Schmidt says. He suspects that soaring aerosol emissions from China may have contributed to the slowdown. Possibilities like this cannot be ruled out, responds Joachim Marotzky of the Max Planck Institute for Meteorology in Hamburg, Germany, who helped write the relevant parts of the latest IPCC report, but there is no evidence for them. While there may be uncertainty about the precise causes of the slowdown, there is no doubt about the big picture. Measurements show that sea level is rising faster than ever at around 3 millimetres a year on average. See drowning by numbers. Right, drowning by numbers. Satellite-based radar shows that sea levels are rising at around 3 millimetres per year as ice on land melts and warming seawater expands. That's 70 millimetres at the top, 0 there, minus 20. Goes back to 1992. At least 1 millimetre per year of this is due to the expansion of seawater as it warms, showing that the ocean is gaining heat independently of measurement of the water temperature. The rest is due to the melting of land-based ice. So if you define global warming in terms of the total heat content of the atmosphere, land and oceans, as most scientists would, then there has been no hiatus. Global warming has not stopped, says Marozetsky. Sea ice is still melting, the ocean is still taking up heat, and the sea level continues to rise. In fact, Trenberth thinks that the process may have accelerated. I've got to get through that in 4 minutes. Delayed action. So what happens next? Does the slowdown mean global warming isn't going to be as bad as we thought? The fact that surface temperatures have not been rising as fast as they were is good news, to the extent that this is due to less heat coming in from the sun or more being reflected into space by aerosols. We have struck it lucky. That heat has gone forever. Increased ocean heat uptake is more of a mixed bag. Much of the heat going into the oceans will stay there. This heat will not warm the atmosphere, bracket good, but it will contribute to sea level rise via thermal expansion, bracket not good, and it will mean the oceans take up less heat in the future, bracket bad. Some of the heat now going into the oceans, though, will slosh back into the atmosphere, leading to rapid surface warming, bracket very bad. Part of the heat is lost, say Trenberth. Some of the heat comes back in the next El Nino. The big question is when. Schmidt and others expect warming in the lower atmosphere will soon speed up again, but there is no way to be sure. Most of the factors responsible for natural variability from solar output to El Ninos can't be reliably predicted, but Trenberth thinks that a longer-term change in ocean conditions called the Pacific Decadal Oscillation is playing a big role. This reverses every 2 or 3 decades as a result of changing winds, and if past behaviour is anything to go by, it will switch phase in the next 5 or 10 years, Trenberth says. If he is right, that would end the slowdown. There is another possibility. The increased ocean heat uptake might result from ways we are altering the planet. Wind speeds have risen over the ocean, for instance. In theory, faster winds could be driving stronger vertical currents and thus pushing more heat down into the depths. If so, the slowdown could continue for years, perhaps even decades. Assuming that isn't the case, and that surface warming will soon speed up, just how much warmer will it get? One method of estimating how much the surface will warm in response to a given rise in carbon dioxide levels, known as climate sensitivity, is to look at how much it has warmed in response to the rise so far. Since CO2 levels have shot up over the past 15 years, but temperatures have only risen slightly, calculations using the latest figures suggest sensitivity is slightly lower than calculations done a decade ago. Climate skeptics have seized upon this, and there are many reasons not to get excited. First, if temperatures in the lower atmosphere do rise very rapidly over the next few decades, these estimates will have to be revised upwards again. Meanwhile, other methods of estimating sensitivity, such as looking at changes in the climate further back in the past or using models, still point to higher values. The bottom line is that talk about global warming stopping or pausing is misleading. It is good news that the world's surface hasn't warmed as fast as previously over the past decade. Yet we have still seen terrifying weather extremes, from unprecedented rainfall in Colorado and record heat in Australia to the power of Typhoon Haiyan. All the while, heat is still pouring into the oceans. All the evidence suggests that atmospheric warming will soon accelerate again, and it could do with a vengeance. Yeah, well, that was a month ago, and last week I heard 3 times on the radio from the Australian Bureau of Meteorology that all the indications are we are moving from a neutral year, whereas we've had 3 La Ninas in a row, we're moving towards an El Nino. So that trickle of water up there, the 5 mils I've had today, I had 22 millimetres in December, That's the first 5 mils in January. If we're going into an El Nino, then we're going into a drought with no soil moisture, and the entire profile is already dry as a dead dingo's donga. So, look out for Tony Abbott's bushfires. The budgie smuggling wingnut has set us on track. Warbles on a lot to YouTube. Ciao.